In this video, we're going to talk about how to solve bearing and distance problems. What I'll be doing in this video is that I'll be starting from simpler problems and advancing to more difficult problems. So we already have problems on the screen. But before we even start solving, there's something I want to tell you. Whenever you are dealing with bearing, since you are dealing with angles measured, there are two kinds of bearings you are going to see. One of them is called true bearings. The second kind you are likely to see is called a compass bearing. Now, for true bearings, you are likely to see something in the form of 060 or say 56 degrees, 056 degrees, or 070 degrees, or let's say 300 degrees. But in true bearings, you are likely to see it as form of pure numbers. So true bearings are normally made up of 3 digits numbers. So if you have something like 7 degrees, you have 0, you write it as 007 degrees. If you have something like 20 degrees, write it as 020 degrees. True bearings are strictly measured from the north. So if I have a point, let's say this is a point P, and I'm to measure the true bearing of 46 degrees or something like that, I'll start from the north and move towards the clockwise direction. So true bearings are made up of 3 digits and they are measured in the clockwise direction. So if I were to measure an angle of say 30 degrees, this would be how it would look like. This angle will be 30 degrees. So a bearing of 30 degrees from P would look like this. This would be the north. Speaking of the north, there are other cardinal points that you're going to be dealing with where you're dealing with bearings. Apart from the north, you are going to deal with the west, you're going to deal with the east, you're going to deal with the south. This is also where compass bearing comes from. Since true bearing is just for the north, the compass bearing deals with both the south and the north. It considers both the south and the north when you're measuring angles. Compass bearing, you see them written in the form of north 30 degrees east or south 50 degrees west. The north and the south are the two key reference points if you are dealing with the compass bearings. Then we are now looking at how close they are to the east and the west. To help you understand, let's quickly jump into the examples so that you can understand how to do the true bearings and the compass bearings. So for our first example, we are asked to make a bearing drawing from a point of 030 degrees. This is a true bearing example, by the way. So let me write solution. Let me say my point is P. So say from point P, I have a true bearing of 030 degrees. Now, I'll come here and say, there's my coordinate system. I can write point P here, which would be this point. Now, this would be my north. This would be my west. This would be my east. This would be my south. Remember, this is teaching you how to draw bearings from a point. So if I have to draw the bearings of 30 degrees, that means from this point, I would measure an angle of 30 degrees in the clockwise direction. So that this will look like this. So this is 30 degrees. Sometimes you can decide to write it without the west, the east, and the south. So you can write it in the form of this. You just have your point. Since your key reference point is your north, you just write your north. Then write your points P. Then you can draw it towards this way in the clockwise direction. So that this will be 30 degrees. So both of them work. So this is the solution for the first example. For the second example, we are asked to find the bearing of 155 degrees. So if we have our north, these are points P. These are north direction, points P. One of the things you need to note about 4 cardinal points is that whenever you have the north, the south, the west, the east, this is the south, this is the north. the angle between north to the east is a 90 degrees angle. The angle from here to here is a 90 degrees angle. The angle from here to here is a 90 degrees angle. The angle from here to here is a 90 degrees angle. If I measure 155, it should fall around here in the southeast region. So this point P, this angle is 155 degrees. Let's look at the compass bearing examples. So for example 3, we are told to find the north 30 degrees east point. Let's assume that the point is P. So if I have my points P here and I have my north direction, I have my east direction, I have my west direction. It's my north, east, and then I have my south direction. This is my point P. North 30 degrees is simply tells me that you are starting from the north and then measuring an angle of 30 degrees towards the east. So I'll be saying this is the north, moving 30 degrees towards the east to be something like this. So this will be 30 degrees. That's it for this example. For the fourth example, we are told to find the compass bearing of south 50 degrees west. We draw our cardinal points. This is north, this is east, this is the west, this is the south. So south 50 degrees west means that south is our reference point, and then we're measuring 50 degrees towards the west in the clockwise direction. So that our angle looks like this. 50 degrees towards the west, we have here as 50 degrees. So that's it for how to draw your bearings from your point. Let's move on to a more complicated skill that you need to learn for you to solve complicated bearing problems. For this one, we would learn how to calculate the true bearing and compass bearing of A from P. So these are the key points we're looking at. Anytime you see A from P, it means that from P tells us that this is the origin we are looking at, the bearing origin we are looking at. Okay, the from is a key word. If you are told to compute a bearing of A from P, you should go to P and look at the angle from that P to your A. For the true bearing of this, if this to this point this is the east direction, by the way. If the angle of this line to this point is 50 degrees, know that for the angle between the east and the north is 90 here. Now the true bearing can be calculated by getting the angle from the north to that particular point. So how do we get this angle? Let's call this angle theta. To get angle theta here, this will be theta plus 50 is equal to a 90 degrees. So that from here, theta can be given as equal to 90 degrees minus 50 degrees. Theta is then equal to 40 degrees. So that's theta. From here, we can simply write our true bearings and our compass bearings. To write our true bearing here is equal to, now if theta is 40 degrees here, theta is equal to 40 degrees, our true bearing will be 40 degrees, because that is the angle of the north to this line that connects PA. Remember, our true bearing is always written in 3 digits, so it will be 40 degrees. Now for our compass bearing, let me write it here. Compass bearing, we are starting from the north as a reference point and we are moving towards the east. So our compass bearing is simply north 40 degrees east. Let's go to example number 2. Now you can pause the video and try to do example number 2 and example number 3 by yourself. So for example number 2, we're already given the angle here. But to really get our true bearing, we need to know the angle from this north direction towards the line that connects PA. Okay, so since we know the angle from here to here, to know the angle from here to here is not difficult. Now this angle, this is supposedly the east, this is supposedly the south. So there's a 90 degree angle here, there's a 90 degree angle here. So that from here to here is equal to 180. So the total angle of our true bearing is simply let's assume this entire place is theta. Theta is equal to 180 plus 49 degrees. So that this is equal to 180 plus 49 is 229 degrees. Remember, our true bearing is the angle from this note to that particular line that we're looking at. So that true bearing here is actually equal to 229 degrees. Therefore, our compass bearing, to calculate our compass bearing, let me redraw this thing so that you have a look at what it looks like. So at this point, our bearing looks like this. This is the north, this is the east, this is the south. Now, our point of connection is these points P. This is a 49-degree angle and it links this way. So this is our point A. Now, to get our P, the closest reference point we have here is the south. The south is the closest reference point we have for any line below this axis here. The north is the closest reference point for any line this axis here. And this line is below this axis. So the south is key point here. Since the south is moving towards the west here, our compass bearing can be written as compass bearing equal to south, and then south is moving towards the west on a clockwise direction of 49 degrees. So this is 49 degrees and then west. So we have south 49 degrees west. So that's it for the true bearing and compass bearing of example 2. Let's look at the example 3. Now for question number 3, we are given our of A from P as 55 degrees in this direction. So to find our true bearing, remember we need to calculate the angle in a clockwise direction from the north to the line joining P and A. If this angle is 55 degrees, let's call the angle outside of it theta. So that to get that angle, we can say theta plus 55 is equal to 360 degrees. Then to get theta, we say theta is equal to 360 minus 55 degrees. From here, we have 360 minus 55 is 305 degrees. So that the true bearing here is equal to 305 degrees. And then to get our compass bearing, now if you notice, we can divide this into 4 cardinal points. So this is the north, and then we have the east, we have the west, we have the south. The angle between the north towards the west is a 55-degree angle. So this angle is a 55-degree angle. Now if we check how this angle interacts with the north and the east and the west, you notice that the closest reference point to the angle is the north. First of all, I noticed that there's a 55-degree angle and it falls on the northwest axis. So we can say the compass bearing is actually equal to north and then a 55-degree angle moving towards the west. So this is our compass bearing. So that's that to calculate bearings around the points. Let's look at another set of examples that will teach us how to use parallel lines and geometry to calculate bearings. So for this kind of problem, we are looking at how to calculate bearings using parallel lines and trigonometry. For the first example, we are told that the bearing of A from B is 035 degrees. What's the bearing of B from A? The first thing we want to do here is to write our solution. The bearing of A from B is 0.35 degrees. What's the bearing of B from A? This is a true bearing question. Since it is A from B, B is the key point we're looking at. So that we can say B is, let's assume that point B is here and towards the north. The 035 degrees from B is somewhere around here on a rough sketch. So this is 35 degrees. 035. Let's say point A falls here. We are not asked to find the bearing of B from A. This is the north of point A. This is the north of point B. There's something I want to show you here. Say you have two parallel lines. Let's assume that these two lines are parallel. If you draw a line in this direction, the angle here would be equal to the angle here. Okay, the idea of this is angle theta, this will be angle theta. We call this alternate angles. Alternate angles. So in this sense, the knot here is parallel to the knot here. So the angle here will be equal to the angle here. So this is also 35 degrees. Now, since we know the angle here, we can easily tell the angle in this straight line. So the angle in this straight line is simply 180 degrees, okay? So to get the total angle from the knot to this point, to enable us get the bearing of B from A, we can call the angle theta. So let's say the angle is theta, and then we say this is 180 degrees plus 35 degrees. And then this will be 180 plus 35 is 215 degrees. Note that the entire angle from here to this point is the 215 degrees, right? So that we can now see the bearing of, therefore, the bearing of B from A is equal to 215 degrees. For our next example, we look at the bearing of Q from P. So I'll clean up space here. We are told to find the bearing of Q from P if the bearing of P from Q is 146 degrees. Since the question says from Q, means that Q is our reference point. So that Q here is, let's say it's this point, and it has a knot angle 146 degrees between the knot and the east here. Supposedly there's a 90-degree angle, so 146 degrees should fall here. So we have 146 degrees here. We now have, this is points P, and there is also an angle here. Is a 90 degrees. This is not. Now, if you notice, there's an angle here. The knot to the east here is a 90-degree angle. To get the angle here, let's call this angle alpha. We can say alpha plus 90 degrees is equal to 146 degrees. So the alpha will be equal to 146 degrees minus 90 degrees. And then this angle will ultimately be equal to 56 degrees. So if this angle is equal to 56 degrees, that means the alternate angle, remember we talked about alternate angle, the alternate angle will be this angle. The angle here is this angle, the alternate angle will be this angle. So this will also be 56 degrees. Now, to get the entire angle from here back to this line, we know that angle here is 90 degrees, the angle here is 90 degrees, angle here is 90 degrees, and the angle here is 56. So to get the total angle, we can simply say, okay, let's this angle be theta. So we just say theta is equal to 90 plus 90 plus 90 plus 56. 90 plus 90 plus 90 is 270 plus 56. Now round up to theta as equal to 326 degrees. And so therefore we can see the bearing of Q from P is equal to 326 degrees. So now that we've known all these things, I think we are ready to go into much more complicated problems in bearing and look at how to really solve bearing problems. Let's move on to the next phase of this video. So for the next part, we're going to be looking at how to apply what we've learned so far. That a ship leaves harbor on a bearing of north 30 degrees east. It sails for 20 kilometers and then turns due east. It then sails for 30 kilometers. What is the distance of the shortest route back to harbor? What is the bearing of the shortest route back to harbor? The first thing you want to do when given a bearing problem like this is to draw a diagram. So I'll say solution. The starting point of my diagram, let me say its starting point is around here. So this will be this is my north point. The question, we're told that ship leaves harbor on a bearing of north 30 degrees east. North 30 degrees east means that we're taking a 30-degree angle from here, like this. So this is a 30-degree angle, right? Then we take a straight line, and then we're told that the ship sails for 20 kilometers. So from this point to the point where it turns east is 20 kilometers. When it sails 20 kilometers, we are told that it turns due east. So from this point where the ship changes direction, we draw another coordinate. So from this point, it turns due east. This is east of north. And then we are told that it sails for 30 kilometers due east. So that means this is 30 kilometers. If we draw the line, look something like this. Then it stops somewhere around here. We don't know the point, but we can safely say it's here. This is the north. This is the east of that point. This is the south of that point. We are told to find the shortest distance back to harbor. So the shortest distance between 2 points, which is the stopping point here, and this point is a straight line. So I'll connect these two things to the straight line. So if you notice, we have a triangle here. The next thing you want to do is to figure out your angles. Now, if this is 30 degrees, by what we've learned so far, the angle here will be the alternate angle. So this will be 30 degrees. From here, we have the south and then the east. So that means from here to here will be 90 degrees. So that the total angle here will be 30 plus 90, which is 120 degrees. We can name the shortest distance here D. Now remember, this is a triangle. And if you're going to solve triangle problems, there are two main rules you want to follow most times. So you have the cosine rule and the sine rule. You're going to be using these two a lot if you're solving bearing problems. And I will leave a tag here for you to refer to them. I've made videos on them before. I would like to tag the parts. So I would like to call this side A is equal to this. This side of side B is equal to this. And then this is D already. Okay. So from here, for the shortest route, using the cosine rule, be D square is equal to A square plus B square minus 2AB cos the angle opposite D. So we'll call that angle capital letter D. If you're calling this angle capital letter D, then this angle opposite A here will be capital letter A. The angle opposite B here will be capital letter B. So that this is the cosine rule. Then from here, we can easily find the distance. Now we know that the distance square is equal to A square, from what we know is 20 square. So this will be 20 square plus B square will be 30 square from what we see here. So this will be 30 square minus 2 open bracket 20 times 30 cosine. The angle opposite D, the distance D, is 120 degrees. So this is cos 120 degrees. Simplify this, we get D square is equal to 20 square is 400 plus 30 square is 900 minus 2 times 30 is 40 times 30, 1200 cosine 120. So from here, we know that D square is equal to 400 plus 900 is 1300 minus 1200. Cosine 120 is minus 0.5. So this is minus 0.5. And then we have D square as equal to 1300 plus, this is 1200 times 0.5 is 600. So that we have D square is equal to 1300 plus 600 is 1900. If we take the square root of both sides, we have D is equal to square root of 1900. So if you take the square root of 1900, you get this as equal to 43.59 kilometers. This is to 2 decimal places. So the shortest distance back to harbor is 43.59 kilometers. So to find the bearing back to harbor, one of the first things you want to do is to get the angle here so that you'll be able to find the angle from the north back to this line, right? That's the key angle you're looking for. But if you can find this angle, you should be able to find the angle from here to here. Now this angle, like you can tell, is angle A. Before we solve that, let me clear up space. To find the bearing of the shortest route back to harbor, like I said, we need to find this angle. So bearing back to harbor, find this angle. The best thing we can use here is the sine rule. The sine rule simply tells us that we can take the sine of a side and its opposite side, and the ratio is always constant. So if we have sine d over d, we have sine a over a, we have sine over b. Now we know b, d and d, and we know side a, but we don't know angle a. So we can pick these two parts and use them for our sine rule. Now from here we have sine d, the angle d is 120 degrees, so this is 120 degrees over the distance of d is 43.59. This is equal to sine a is what we are looking for. A is what we are looking for. So the opposite side is 20. From here we can find a. If we cross multiply from here, we have sine a times 43.59 is equal to 20 times sine 120. So that we have sine a as equal to 20 times sine 120 over 43.59. From here, to get a, we can take the sine inverse of both sides. So that a is equal to sine inverse of 20 times sine 120 over 43.59. From here, we have this as equals a is equal to 23.41 degrees. So to really get the bearing back to harbor, it's important we look at this part properly. So I'll draw out this Cartesian points here. So this will be the north, and then remember the ship comes directly from the west. So this is the line we are interested in, one of the lines we're interested in. And then we have this angle. This angle is 21.41 degrees from our calculation. Now the bearing back to harbor is the angle from here to here. We know that angle from here to this point of south is 180 degrees. To get the angle from here to here, we can use the knowledge that since the angle from the west to the south is 90 degrees, that means this angle here will be 90 minus, this is 23.41, by the way, that was a mistake. So 90 minus 23.41. From here, we know that 90 minus 23.41 is equal to 66.59 degrees. So the total angle from here to here is 180 degrees plus 66.59 degrees. Now, if we are considering the true bearing, that means the bearing back to the shortest routes. So if you add the two angles up, you get equal to 246.59 degrees. So that means to say the true bearing from this point back to harbor is simply 246.59 degrees. So that's it on how to solve this kind of problems. But let's take a look at one extra example. For this example, we are told that two planes P and Q take off from an airport. A short time after takeoff, P is 20 kilometers away from A on a bearing of north 85 degrees east, and Q is 35 kilometers away on a bearing of 200 degrees. What is the distance between P and Q? So the solution here is, the first thing we do, like I said, is to draw a diagram. Now, we assume that the airport is somewhere around here. I'll draw my north, east, south points from here. This is my north, this is my west, this is my east, this is my south. I'll call this airport A. Now, if the first plane takes off at north 85 degrees east, north 85 degrees east falls around here. So this is 85 degrees, by the way. it supposedly travels for 20 kilometers in this direction. So this is 20 kilometers. Then gets to a new point. That new point will have its own north, east, west coordinates. So this is north, east, south, west. So let's call this point P because it is the point where plane P stops. The point where our course rate up to in our question at least. Then for the second, we are told that we have the plane fly 200 on a bearing of 200 degrees. So if it flies on a bearing of 200 degrees from here to here is 180. 200 degrees should fall around here. So let's say this point Q. This is plane Q, so let's call this point Q. This is the north. This is the east. Now from here to here is 180 degrees. This will have to be 20 degrees. The shortest distance between two planes, we use a straight line. So this is the shortest distance between the two planes. From here, we can call this distance D. Let's name all the parts. So we know that this is 35 kilometers, right? The distance from the airport to where plane Q is considered to end. Then we know that this is 20 degrees. We know that from here to here is 200 degrees, from here to here is 80 degrees. So to get this angle, angle A, for angle A, we just say 200 minus 85 degrees. Like I said, for us to get to this point, from here to here is 200 degrees, and from here to here is 85 degrees. On point of interest here is the one inside this one. So to get that angle, we say 200 minus 85 degrees, which is equal to 115 degrees. Now to get our distance between 2 points, we can simply use cosine rule like we did before. So to solve for the shortest distance between 2 points, we use the cosine rule here. The cosine rule here will state that we have d squared is equal to 20 squared. So we take the square of the other two sides and add them, plus 35 squared minus, we take the 2 times or the other two sides, 20 times 35, then we take the cos of the angle opposite angle D. Cos of that angle is 115 degrees. So this is 115 degrees. D square is equal to 20 square is 400 plus 35 square is 1225 minus 2 times 20 times 35 is 1400 cosine 115. D square is then equal to 400 plus 1225 is equal to 1625 minus, we have 1400 times cosine 115. From here, this is minus 591.665. If we use minus times minus here, we have d square is equal to 1625 plus 591.665 is 2216.665. And then we have the square root of both sides. We take square root of this, square root of 2216.665. This is equal to 47.081 kilometers to 3 decimal places. So that's it on how to solve questions in bearings and distance. If you like the video, please leave a thumbs up. If it really helps the channel, share with your friends and subscribe. Thank you for watching.